In this video of our velocity sequencer build-out, we're going to take a look at creating a 16-step single-value sequencer in a Max4Live device. This sequencer needs to be synced with Live's transport and it needs a user interface. Let's start with the device we made in the last video. There are many ways to get transport information from Live into a Max4Live device. In this situation, we're going to use a synced phasor ramp. A phasor ramp is an audio signal which goes from 0 to 1 over a given amount of time. We can use the value from a phasor to tell us where we are at any given point in a bar or other loop time duration in our live set. Let's create a phasor tilde object with the attribute at frequency space 1 space 0 space 0 space bars dot beats dot units space at lock space 1 and hook it up to a meter tilde object. Start the transport in Live. You can see that the audio display in the meter object goes up steadily and then drops down to repeat the cycle. What's going on here is explained by looking at the arguments we gave the phasor object. At frequency space 1 space 0 space 0 space bars dot beats dot units tells the phasor object that the period of time in which it goes from 0 to 1 is equal to the current bar length in our live set. This means that if you change the time signature in Live to 3/4 or anything else, this phasor will still loop correctly over one bar. The lock1 attribute setting tells the phasor object to lock its starting time to the beginning of the bars in the live set. So no matter what tempo, the ramp will always be at 0 on the first beat of every bar. The phasor object is an extremely accurate way to capture Live's transport state, but it outputs an audio signal. In order to use the data we're getting from the phasor object in our device, we need to convert this audio data into numerical data, which we can pass around as max messages. We're going to sample the output of the phasor object. We can do this with the snapshot tilde object. The snapshot object takes an argument for the interval it uses to sample incoming audio. Let's give it a value of 5. This means that every 5 milliseconds, the snapshot object will output the sampled value of audio it receives at its input. If you hook up the message box below the snapshot object and start Live's transport, you will see the audio ramp from the phasor expressed as a float in the message box. Our sequencer is going to be a 16-step sequencer. Later on we can change that, but it's 16 steps for now. We are going to use this phasor data to tell us which 16th division of the bar we are currently in. We want to turn the phasor ramp, which is 0 to 1, into an integer between 1 and 17 to tell us which step we are in. Add a scale object and type in it 0.1.117. The starting index of our first step is 1 and we have 16 steps, so we need to scale to 1 plus 16. If you want to check this output, hook up a message box to the outlet of scale and start Live's transport to watch how it works. In order to avoid a bunch of extra output flooding into our patch, we're going to add a change object after the scale object. That way we only get one number output per step. The change object filters out repetition in a sequence of numbers, only outputting when a new value is received. Add a number object after the change object so that you can monitor the step position in Live's transport. Now we'll add our user interface object. For setting the values of our sequencer, we're going to use the multi-slider object. Create a multi-slider object and open its inspector. Let's set the number of sliders to 16 and the alternating candy cane colors to 16 to give it some variation. While we're in the inspector, we need to adjust the range of the sliders so that they are set from 0 to 127. This range will represent our velocity values. We also want to change the slider style from thin line to bar to make it easier to see. Hook up the output from our number box to a message box containing fetch, space $1 and connect that to the left inlet of the multi-slider object. Now connect another number object to the rightmost outlet of the multi-slider object. Hook up another message box to the outlet of the fetch $1 message box to see what's going on. You can see that the $ symbol in the message box is being replaced by the value of the incoming integer. This new message is being passed on to the multi-slider object to query its state. Lock the device and set some values in the multi-slider by mousing around inside it. If you start live transport, you will see that the multi-slider responds to the fetch message by outputting the value for that step. This gives us our sequence single value and also the UI setting for that value. Now select the multi-slider, the index number object, and also the sequencer output number object, and add to presentation. Now if we click presentation mode, you'll get a tidy view of our velocity step sequencer so far. This gives us the velocity values we will be using to create the sequence sound in the next video.